So the Huygens principle states each point of the wavefront is a source of the secondary wavelengths, and the wavelengths traveling or emanating with the speed in all directions emanating with the speed of wave in all direction. These wavelets emanating from the wavefront is referred as secondary wavelets, and if we draw the common tangent to all the spheres, then we obtain the position of the wavefront later time t, that is after time t. So that is the statement of the Huygens principle. Now we discuss how we form the or how we find the wavefront after time t. So first, this is the point source. That one I am going to take O. So O is the point source, and we know one wavefront. So this one is the wavefront. I am taken that one as P and P1. So we know this wavefront at time t is equals to 0, right? Next, this wavefront has number of points. That is, the wavefront has number of points. Place means here I am taken 1 point, and here I am going to take 1 point, and here 1 point, right? So I am considering 3 points on this wavefront. So what the statement says is each point I am taking here 3 points. So this point acts as the source for the secondary wavelets. So this one acts as the source for this wavefront. Who is the source for this point? That is for this wavefront. Here we have 3 points, and each point acts as the source for the secondary. That is what we are going to find the wavefront. For that wavefront, this point acts as the source. We know that is the wavelets emanating with the speed of wave in all directions. From here, the wavelets which are going to, that is from the source, the wavefronts are moving in the forward direction. From this point also it is moving with the speed of wave. They also mention the wavelets emanating from the point is travel with the speed of wave. That is, we know speed is equals to distance divided by time, right? So speed is v. We want to distance from here, how much distance it is travel for the time t. We have to find at time t tau. So when time travels, that is when time passes, for this time we have to find at what distance the position changes for this wavefront. That is, distance is equals to speed is v and t is tau. So this wavefront is travel with the speed v, that is all the points also travel with the speed v. Then the distance is v into t. Now we have to draw the sphere of radius vt. So this is the distance, nothing but the radius we also call as distance. We have to draw the sphere. We have to draw the sphere with the radius v into t. So from here, from this point, here is the distance. So if we complete this one, we get one sphere. So if we complete this one like twice here, so this is the sphere I am getting. If we draw the sphere with the distance, that is radius v into t. So this one is the sphere, right? From every point I am going to draw the spheres with the same radius. Same radius. Like this. Next, from this point, if I draw here. So these are the spheres. So these spheres, next we have to draw common tangent to all these spheres. If we draw the common tangent to all these spheres, we get if this line represents the common tangent for these spheres, then we get the wavefront, that is wavefront after the time t. So that is here this one I am taken as r and it is r1, that is after time t is equals to tau, right? So similarly, if we draw here also one tangent, then here d d1, right? So for this wavefront, O is the center and r dash becomes the sphere. So this for this wavefront, this is also the spherical wavefront for the center O. By this way, we get the position of the secondary wavefront, that is after time t or after time tau. So from the principle, first we are considering on source. From source, we have known wavefront, that is P1 is the known wavefront. From this wavefront, I am considering from this wavefront we have several points. Out of several points, I have taken 3 points. So these 3 points acts as the source of secondary wavelets. That is from this point, the light travels in all the directions. That's why we are going to draw the sphere, because it travels in all the directions like this. So for how much distance it is traveled, that is we are going to draw the sphere of the radius v into t. So this one is the radius, that is v into tau. Tau is the small time. So here is the radius, then here also we get the same, that is v into tau. So this one is the forward wavefront and this one we get d1 is the backward wavefront. These two are at the same distance from P1 and these two are in spherical shape. Next, after drawing the spheres, we have to draw the common tangent for those spheres. That is common tangent to all the spheres. Then we get the new position of the wavefront. That is position P1 will travel to R1 after the time t. So this one is the Huygens principle, right? So if we understand this one, then we can easily understand the concept of reflection and refraction by using the Huygens principle. Okay. So here Huygens also says that for forward wavefront, so R1 is the forward wavefront. For this forward wavefront, the amplitude is maximum. For forward wavefront, amplitude is maximum, and for the backward wavefront, that is d1 is the backward wavefront. For this wavefront, the amplitude is 0. For backward wavefront, amplitude is 0. That is, we are going to neglect d1 because here we getting the amplitude. The Huygens states that so this one is 0. So this amplitude is 0, and the wavefront which are traveling into the forward direction, the wavelets or the wavefronts which traveling in the forward direction, it has the maximum amplitude, and the wavefront which travel backward, it has 0 amplitude. That's why we can neglect this one. Then we get 0 P1 and the wavefront are R1. Okay. So this is about the Huygens principle. So you have to. So the statement is very lengthy. You have to remember. First, starts from each point of the wavefront. That is, this wavefront is the known wavefront. From here, we are going to start from this point. That is, from this wavefront, each point is a source of the secondary wavelets. So this one we call as secondary wavefront. This one is the secondary wavefront. So that one is the secondary wavefront. So here secondary wavelets or secondary wavefronts. So here secondary wave secondary wave fronts. So first point is each point of the wavefront is the source. So actual source is O and the points which are on the wavefront acts as the source for the secondary wavelets. That one is the first point. Next, the wavelets emanating with the speed of wave. So from here the wavelets which are traveling with the speed of the wave, that is V. Next, the wavelet emanating from the wavefront from here to here, the wavelets which are coming, that wavelets are called as secondary wavelets or secondary wavefront. And if we draw a common tangent, so this one is the common tangent to these spheres, then we get secondary wavefront. And one more is for forward wavefront amplitude is maximum and for backward wavefront the amplitude is 0. So this is about the Huygens principle. So in the next class we will discuss reflection and refraction by using the Huygens principle. Thank you.